poll, so let's try that one more time. Okay, got it. Okay, cool. So then, I guess it didn't open. Let me make sure it's streaming properly. So, I do encourage everyone to be subscribed to my YouTube with your notifications turned on. Okay, so it's working. I'm not gonna. Okay, so let's see. Let me start here for right now. I'm gonna go ahead and save attendance. Every time I save, somebody comes into the room, but that's okay. Because I just don't want to, because sometimes it crashes and I don't want to lose my attendance that I've taken. Okay, so let me see as far as announcements. So the first thing is there is a poll, so just go ahead and take the poll. Pretty much the suggestions are we can either continue, we probably will continue the homework. So this week is the end of week 2. So this week we're working on section 2.5 rational functions. So we can probably kind of keep making our way through as many of those homework questions as we can. I think next week we're going to start section 3.1, but the week after that we can anticipate exam 1, right? So I think I scheduled the exams for weeks 4, week 8, and week 13. I think it is. Let me get these students. Start locking the attendance at like 2:15. All right. Because I mean, maybe not. I might stop taking attendance at 2:15 because this is kind of like irritating. The best, you just want to be waiting like 10 minutes before the start of class. That's the best thing.
I have a quick question. Sorry.
Go ahead.
So the homework on Pearson is due by next Wednesday before class time, correct?
Let me see. So the homework for this week is due at the start of next week. Usually it's like that Monday. All right. Do that Monday, but you can work on any assignment past the due date with only a 10% late penalty. So there are soft deadlines for all assignments throughout the semester, but then there's a hard deadline of like May 1st at midnight, going from that Sunday going into Monday for all deadlines, for all assignments. But yeah, but there is the deadline is like the start of the next week at the start of class. But you can actually work on it past that time with unlimited attempts with only a 10% late penalty. Okay, section 2. And like it's kind of frustrating with the attendance because I'm using Starfish and like it takes so much to just open up the attendance screen. But anyway, okay, we're here. Let me see if I can think of anything else. Say another hand, or did that question already get answered?
Already answered.
Okay, got answered. Okay, cool. Okay. So let me see if I can pull up the poll really quickly. So if I go here, let's see if it's live.
Oh, actually, another question. So, am I able to leave? Or
synchronous? Like once you get your attendance, I mean, you're not obligated to stay. The intent is for class time to be like a Q&A, so like a study session.
So every time
okay. Go ahead.
So every time I join, once you admit me, I can just leave. Is that how it works, or like do I have to wait to a certain time to leave?
I take attendance as I let you all into the room. So once you gain access to the room, if I don't like stop you, then that means you got credit, and you know.
Okay. Thank you then.
I don't want to be like that's kind of like a. I don't want to be like this. That's kind of like a ploy or anything, but it kind of is a little bit. But again, I feel like it's okay. As long because I know that some students are ahead, and I don't want to like waste people's time. You know, and like if you're ahead and you feel comfortable, then it is what it is. But we're gonna be here, and I'm gonna go through it. You know, you just want to definitely make sure that your stuff is covered. And again, man, I need to suppress the audio because it's totally distracting. Let me see. I can't think of anything else, so I'm going to just go ahead and kind of keep making my way through the homework. And again, I do acknowledge that some people are ahead, which is the intent, and I think that's okay. I'd rather you be ahead than behind. Go ahead. You have another question?
Yeah, I know you were just saying that you might, or I might have heard you wrong, but you said you might start just taking attendance at 2:15.
So if class, for instance, like like so if class starts at 2, like I just don't want a whole bunch of people showing up late. Like I don't mind you like getting attendance and leaving, but I really don't want a whole bunch of people showing up late. Because it just kind of throws off the rhythm, it slows me down. But right now it's okay. Just the best thing is just kind of be here. Like if class starts at 2, just kind of be waiting, starting at like 1:50. I usually try to get a little bit early, go ahead and take attendance. And then once we kind of get going, you know, again, you're not obligated to stay. I just don't want a whole bunch of people showing up late, because again, after about 2:15, you know, that's usually when I'll cut things off. But
Okay.
you know, yeah.
I just wanted to make sure, because I was thinking you were saying you were only going to take attendance at 2:15, and I was like, well, if I get on at 2 o'clock, I leave at 2:05. But never mind.
Yeah. But again, the way you know is because I take attendance as I let students into the room.
All right.
Okay. Yeah. Okay. So if we continue where we left off from last time, let me see. The poll didn't seem like it was working, but that's okay. So we were working on section 2.5 rational functions, right? And I think we made it through question. I think we got like 9 questions completed. So we're gonna start here with question number 10. And we're asked to find the vertical asymptotes of the graph of any, right? So in this one, the vertical asymptotes occur where any x that makes the denominator 0, right? Provided that x does not make the numerator 0 as well. For instance, x equals 3 makes the denominator 0, and it does not make the numerator 0. So therefore, this is a vertical asymptote. So let me kind of do it like this. That's okay. I'll do that in a minute. That's not too bad. So we see if we plug in x equals 3 into the denominator, it gets us our 0 there. So the vertical asymptote is going to be x equals 3. X equals 3. Okay, let's go. Next question. Okay, so this one again, let's actually get a copy of this one, and we need to kind of expand it out and take a look at it. Some of these are nuanced. Take this. This is so rich. Oh no, come on. Okay, let's go here. Let's just take another screenshot. Like this. So we're asked to find the vertical asymptotes of this guy, right? We're looking for the vertical asymptote. So now with something like this, you definitely want to write it in expanded form first, right? You want to factor the numerator and the denominator. So if we're going to factor this guy, let's see. If you need assistance, or if you want more practice on factoring, which I know that most of the students need, there is a handout section in our Blackboard where I have a whole chapter, a copy of a whole chapter that kind of lists out all the scenarios that you'll come across with factoring. So it's a good idea to kind of take that and sit down with like the tutors or somebody that's comfortable with this and go through that if you need more practice on factoring. Okay. So with this, the numerator, this is a special factoring scenario, right? This is a special factoring of a binomial. So we have something squared minus something squared, right? So then this factors into x minus 1 times x plus 1, right? And then with the bottom, okay, we're looking for something of this form, right? Now, we're looking for 2 numbers that multiply to give us negative 24 and add to give us a positive 2, right? So let's do this in the following way. We want to start with that negative 24, right? Now what 24 is, what, 6 times 4? So this is 4 is 2 times 2, 6 is 2 times 3. So then 24 is basically 8 times 3, right? So what we're going to do, we're going to go through all the combinations of the factors of 24, and we're going to stop at the line that adds up to positive 2, right? Now, I know in this example, this one is a lot easier to kind of find those numbers. I'm just showing you this technique because sometimes they're not this easy. And so it's like when they're more challenging, you can use this technique that you see me doing in purple to find those two numbers, right? And then once you get to the end of this list, there aren't any other combinations. So then you can confidently say, oh, this is a prime factor, right? So let's go through all the combinations of the factors. So -24, the first one is going to be 1 and 24, right? But this line adds up to 23, so these are not the two numbers that we're looking for. Okay. So then we can do 2, right? If we use this 2, what's left over? 4 times 3 is what? 12, right? If we use the 2, then we have 12 left over. But notice that 12 plus -2 is what? 10. So these are not the two numbers that we're looking for. Let's keep going. We can do 3, all right? Because we have a 3 right here. If we use this 3, what do we have left over? 8. Notice that -3 plus 8 is 5, so we're almost there. These are still not the two that we're looking for, but let's keep going. We can do 4, all right? I think we got a 4 in there. So notice on the left, I'm just going 1, 2, 3. Next, I'm going to do 4. And let's see. If we use 4, if we use these guys, what's left over is 6. All right. Notice that -4 plus 6 adds up to +2. So then I know somebody's in the waiting room. These are the two numbers that we're looking for, right? So then we're gonna say, we can do like a +4, a +6, and -4. Let me let the student in really quickly. I forget who that was. He needs to change his name. I remember we had this conversation last time. I just don't remember who it is. Greetings, Mr. Exclusive on. I don't remember. I know we had this conversation last time. I don't remember which student you are.
Devon Sidney.
And I can't find it. I think this is the student. I hope I got the right student. I don't know. Okay. But yeah, I definitely would encourage each person to like show your update your name. Okay, I got it. Yeah. Update your student name so that when you log in, it shows your student name so I know who you are. That helps out a lot. Okay, let me hit this, hit next, edit. Okay. I think I saved it, so I'm not gonna worry about that. And then let's see, where were we? So we found the two numbers that we were looking for, right? These added up to +2. Okay, so now we have the original incompletely factored form. So now it's clear what values of x make the denominator 0, namely x equals -6 and 4, right? Okay, and then also notice that when you plug in -6 or when you plug in 4, they don't make zeros in the numerator. That was a big part, right? Because if they made zeros in the numerator as well, then they would not be vertical asymptotes. They would actually be holes or gaps in the graph. Okay, so we got -6 and 4 type equations and use commas. So we got x equals -6, comma x equals 4. Okay, we're gonna go on to the next one. Vertical asymptotes, right? So now, if we focus on this, right, and we look at the denominator, for the vertical asymptotes, we're looking for what values of x make the denominator 0, right? Now, if you think about this denominator, the parent function is x squared. So if you just think about x squared by itself, that graph is going to be a U-shaped graph where the vertex is at the origin, right? So then if we add a +6 outside the parabola, that's going to move this U-shaped graph up 6 units, right? So transformation from college algebra 1. So this, if we just focus on just that denominator by itself, that's going to be a U-shaped curve that's been shifted up 6 units, right? So then if we're trying to find the zeros of the denominator, i.e. when that graph crosses the x-axis, well, because you have a U-shaped graph that we shifted up, it's never going to cross the x-axis. So that means we don't have any x's that make the denominator 0. So that means there are no vertical asymptotes. Hopefully that logic makes sense, right? So there are no vertical asymptotes here, right? There's no value of x that's going to make the denominator 0. Okay. Now for the horizontal asymptote. So hopefully you have at least found my lectures on YouTube, right? I know they're math lectures, but they're there. I do acknowledge that students generally do not watch them, but again, I did my part. I made them available. I create them, and so I say that to say, in the lecture, I kind of explained or kind of touched on this idea of how do we find horizontal asymptotes. There's a 3-pronged test that we have to do to find the horizontal asymptote. And so basically what we're doing is we have to compare the degree of the numerator to the degree of the denominator, and then it's going to be one of 3 results, generally speaking, right? So to find the horizontal asymptote, the degree of the numerator in this case is 1. The degree of the denominator is 2. So then this is one of the cases, I think it's the first case where the degree of the numerator is less than the degree of the denominator. So then that means our horizontal asymptote is going to be y equals 0, right? So that's the first part of that test, right? So that was the first outcome for that test. So the horizontal asymptote is going to be y equals 0, namely the x-axis. So another horizontal asymptote, right? So we're asked to find the horizontal asymptote of this guy. So again, to find the horizontal asymptote, we compare the degree of the numerator to the degree of the denominator. The degree of the numerator here is 1. The degree of the denominator is 1. So this is actually the second outcome for that test. So then the second outcome says when the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is going to occur, is going to be the ratio of the leading coefficients, right? So the leading coefficient for the numerator is -3. The leading coefficient for the denominator is 2. So then it's just going to be y equals -3 over 2, right here. Y equals -3 over 2. And again, you just have to stop me if any of this is not clear, if you have questions about anything. So here's another question on horizontal asymptote, right? Okay. So this is actually the third case for the 3 tests that I was speaking on. So now, if we look at the degree of the numerator here, the degree of the numerator is 3. The degree of the denominator is 2. So this is case 3, where it says, if the degree of the numerator is larger than the degree of the denominator, then there's no horizontal asymptote. So this is an example of something that has no horizontal asymptote. Graph, we have 1 over x plus 3. So what we can do here, we can actually just use transformations from college algebra 1, where we can start with the parent function or base function of 1 over x, the reciprocal function. It's kind of like this, I don't know how to describe it. It looks like either b or d, right? That's the general shape. But then we have to account for the vertical asymptote, right? So because that plus 3 is inside our base function, that moves our graph to the left 3 units. Another way you can kind of visualize this or interpret this, if you identify the vertical asymptote is going to be what? X equals -3, because the -3 makes 0 in the denominator. So that's the same as the graph shifting to the left 3 units, right? So the only one that has the proper shape and that's been shifted to the left is B. A and C are the completely wrong shapes. And then I think D was shifted up. So the only one that's been shifted to the left 3 units is B. Okay. So find, okay, now we're asked to graph this one. Let me see, I can see, okay. So we can kind of keep going with like the asymptote discussion. Let's start off by like finding the intercepts, right? So like if we consider the y-intercept, to find the y-intercept, if we set x to 0, if we set x equal to 0, we're going to get 0 over -9, which is ultimately 0. All right, let me kind of say this really. So on the discussion on zeros, let me see. 0 over some number, this is okay, right? So this is going to be equal to 0. But some number over 0, that's a KO. You want to knock that out. So that's going to be undefined, right? That's going to be undefined, right? And then, I mean, yeah, so 0 over some number, that's okay. That's going to be equal to 0. Some number over 0, that's a KO. So that's going to be undefined. And then just as an auxiliary thing, if you have 0 over 0, that's going to be a hole in the graph, not a vertical asymptote. This one here, this one is the vertical asymptote. Vertical. This one is a hole in the graph. This one is a hole. So if you find the x value that gives you the purple, that's not a vertical asymptote, that's going to be a hole in the graph. Okay. Okay. So here, so I think if, for instance, if we wanted to define the y-intercept, if we set x equal to 0, we're going to get 0. All right. So when x is 0, y is 0, so that means that our graph should pass through the origin. I think with that piece of information alone, we can choose the graph, because none of the other, there's only one graph that passes through the origin. All right. If you look at B, that one doesn't pass through the origin, nor does C. So right off the bat, it should be A by process of elimination. If you identify the asymptotes, for instance, the vertical asymptotes. So if we were to factor that denominator, we got something squared minus something squared. That factors into x minus 3 times x plus 3. So that means plus or minus 3 are vertical asymptotes, which you can see in part A. Part C only has one vertical asymptote, so it can't be C, right? And we've already identified it, but. And then also the other part you can look at is the horizontal asymptote. So if we compare the degree of the numerator to the degree of the denominator, they're the same. So then we take the ratio of the leading coefficients. So then we get y equals 1 is our horizontal, all right? And I think that's still part A. Okay, so I'm just gonna go with E and final check. So then we actually use the 6-step process to graph this rational function. Okay, so let's start off with the, I mean, we can start off with the intercepts. Like if we do y-intercept, if we set x to 0, we're gonna get 0 over -4. So it should pass through the origin. I think all of these graphs pass through the origin, so we can't use that here. We can use it, but we need more information. So then let's identify the vertical asymptote, right? So the vertical asymptote in this case is going to be x equals 4, because that's going to give us like 8 over 0. So that means we have a vertical asymptote. So x equals 4 should be a vertical asymptote, right? So it could be A, it can't be B, the vertical asymptote's in the wrong position. It can't be C, and it can be D. So it's either A or D, right? So if we found the vertical asymptote, let's go ahead and find the horizontal asymptote, if any. So if we compare the degree of the numerator to the degree of the denominator, they're the same. So we take the ratios of the leading coefficient, which is going to be 2 over 1, which is just 2. So y equals 2 should be a horizontal asymptote. So between A and D, the only one that has a horizontal asymptote of y equals 2 is A, right? So we're going to take A and check. Hopefully that makes sense. Again, you have to stop me. Like if you don't stop me, I'll just kind of keep powering through. You have to like stop me and go back if you need me to kind of explain something in greater detail. Okay, let me check something. So I might have to take care of you guys. I am going to do this. Use a 7-step method to describe. Use a 7-step method described in the book to graph the following rational functions, right? So first, it asks us to determine the symmetry, right? So for symmetry, what we need to do is replace each x with negative x and simplify. Now, I was about to write it out, but if you look at this, right? If we replace each x with negative x, like for instance, if you focus on the numerator, negative x times negative x is going to be positive x squared. So if you replace all the x's here with negative x and simplify, you get back to the original. All right. So then whenever we have f of negative x, if I need to write this out, I can, just let me know. But whenever we have f of negative x equals the original, that's the definition of a function being even, which is the same as y-axis symmetry. Right. So this part is a discussion on symmetry in the sense of a function being even versus a function being odd, and then how that relates to y-axis symmetry and origin symmetry. Okay, let's go ahead and check and on to the next one. Find the y-intercept. So to find the y-intercept, we set x to 0, right? If we set x to 0, in the numerator, we're going to get 0. In the denominator, we're going to get -4. So then 0 over -4, that's 0 over some number, that's okay. So that's going to be equal to 0. So the y-intercept is the origin, so I'm just going to hit 0. And x-intercept is going to be the same. X-intercept, you would set y to 0, but a fraction or rational function is only 0 when the numerator is 0. So long story short, it's going to be the same number, right? So now for the vertical asymptotes, we want to find those values of x that only make the denominator 0, right? So if we set x squared minus 4, if we set that equal to 0 and solve, remember that's a special factoring that factors into x minus 2 times x plus 2. So that means plus or minus 2 are our zeros we're looking for. So we're going to put -2, comma, +2. So then for the horizontal asymptote, we compare the degree of the numerator to the degree of the denominator. In this case, the degree of the numerator is 2, the degree of the denominator is 2, they're the same. So then we take the ratio of the leading coefficients, it's going to be 5 over 1, which is just 5. Plot the points between and beyond the x-intercept and the vertical asymptotes, right? So we just chose a few additional points. Also, we can use the fact that this graph has a y-axis symmetry, right? So because it's symmetric, whenever we get a point on the left, we automatically get another point on the right. So now with this one, what I'm going to do, I am going to pull up my trusty dusty rusty. File. Let me go like this. So just trying to get this to behave. There we go. I know it's a little bit small, but I'm gonna have to do it. So now, instead of like, basically we want to plug all these x values in and find the corresponding y. What I'm going to do is put this into my graphing calculator. So I'm going to go to y equals, and my numerator is 5x squared divided by x squared minus 4. Okay. I'm going to go back to the home screen. I'm going to hit second mode so I can quit that screen. Then now, if you look at the calculator here, on the right-hand side, there's a button that says clear. To the left of that, there's a button that says VARS. I'm going to click on that button. I think it stands for variables. I'm going to go to the right where it says Y variables and click on number 1 for function and click on number 1 again to call on the function I just typed in Y1, right? So now when X is -4, right, it's basically like I'm plugging -4 into the function. the corresponding y, now let's do this. Let's recall, I'm gonna go to math. I want this as a fraction. So when x is -4, the corresponding y is 20/3, right? So here, I'm gonna type 20/3. Now, because this graph has y-axis symmetry, +4 is gonna have the same result. So this one's also gonna be 20/3, okay? Then I'm gonna do when x is -3. So we got 9. So when x is -3, we get 9. That automatically gives us +3 as well because this graph is even. So we're gonna put it there. Can I just hit tab? No. Okay. So then when x is a -1/2, insert 1. -3. Okay. And okay, we got those components. We got a solid 10 minutes, right at about 10 minutes remaining. So let's kind of keep going. Let's see. Yeah, I'm gonna get rid of this. So I think about that for right now. So then using the information determined the above, let's see. So let's kind of go back to the first one. We had that it has y-axis symmetry, right? Y-axis symmetry. So it can't be C because C does not have y-axis symmetry. It's either A or B, right? So if we were to guess at this point, we have a 50-50 chance. Chance favors the prepared mind, right? If we were to just guess off the rip without any kind of preparation, then we have a 33% chance of getting it correct, 1 out of 3, right? But then with that first one, it says that it has y-axis symmetry, so no, we know it can't be C. So now we got a 50-50. If we were to just guess at this point, those are pretty good odds, almost greater than 50, if we just guessed at this point. Again, chance favors the prepared mind. Let's see, the y-intercept, the x and y-intercepts were the origin. So I think both A and B both pass through the origin. So let's take another piece of information. The vertical asymptotes are ±2. And it looks like they both have the same vertical asymptotes of ±2. So then the horizontal asymptote is y = 5, right? And the only one that has a horizontal asymptote of y = 5 is A, between A and B, right? A is the only one that has it. So then it should be A. So use the 6-step procedure to graph the following rational function. Okay. So let's think about this. We could start with the intercepts. I'm actually going to start with the asymptotes, right? So if I consider the vertical asymptotes, if we plug in 3, that's going to give 0 on the bottom, and that's going to give us like what, 18 on top. So x = 3 is one of them. Looks like there should be at least 2. So it can't be A or B, right? Because those don't have 2 vertical asymptotes. So x = 3, it could still be C or D. I think x = -2 is the other one. And I think they both kind of have that same asymptote. So then now if we wanted to talk about the horizontal asymptote, we would need to expand that denominator, right? Because right now you might be tempted to say, oh, they have the same degree, so it's a ratio of leading coefficients. But again, first we need to expand the denominator. Now, if you expand it out, the leading coefficient is now just going to be x². So now you should be able to see that the degree of the numerator is less than the degree of the denominator. So that means y = 0 is our horizontal. So that doesn't help us with either of these. Let's look at our intercepts. For instance, I usually like to start with the y-intercept. Oftentimes the y-intercept is easier. So to find the y-intercept, we set x to 0. And if we do that, that's going to give us 9 over, I think that's a -6. Is a -3/2 for our y-intercept, -3/2, right? Okay, I think that was what we needed. So if you look at C, the y-intercept is positive, but you look at D, the y-intercept is negative. So then I'm just going to go with D from that point. So at first I looked at my asymptotes. And then I just went back and kind of kept pulling more information until I got a clear choice. All right, so then I'm just gonna go with D and submit that one. That was it. Let me see the time. I don't want to keep you longer than 5 minutes. Okay, oblique asymptote. Now, I don't think I got to this question with my class from earlier, right? So the oblique asymptote, now that occurs when the degree of the numerator is larger than the degree of the denominator by 1 degree. For instance, the degree of your numerator might be power 4. That means your degree of your denominator will be power 3. And so when the degree of the numerator is larger than the degree of the denominator by 1 degree, then that means we have an oblique asymptote. And so basically an oblique asymptote is going to be, it's pretty much the graph kind of tapers off and like it kind of approaches this line, some line like y equals mx plus b. So to find that line, what we're going to do, we just need to do the polynomial long division. And the answer from the polynomial long division is going to be the equation of our oblique asymptote, right? So let's kind of write this one out. Let's write this one out. And we can actually, let me get a copy. Let's go back. Let me get a copy of this. Right here. So now we're finding the oblique asymptote. This comes from, let me see, this is question. It comes from section 2.5, question 73. So again, this is 21. This comes from section 2.5, question, was it 23 or 30? No, 73, neither. 73, come on. So then we're asked to find the oblique. Okay. So let's do the polynomial long division. So then here, I forget the nomenclature, like this is divisor, dividend. I think this is a divisor, but x squared goes here, right? And then now we're gonna write this numerator, but we need to make sure that every exponent is accounted for, right? Because this one is power 3, this one is power 0, so we're missing 2 and 1. So we need some placeholders, right? So then we start with x cubed. Now we're gonna introduce some placeholders. We're gonna say plus 0x squared plus, a matter of fact, let's switch that from purple to this one because it's very easy to miss this, right? Plus 0x, and then we're gonna say minus 4. So now when we do our division, first thing we're gonna do, we're gonna say x cubed divided by x squared. So x cubed divided by x squared gives us what? Just x. So I'm gonna line up my like term, so x goes here. So now on the diagonal, we multiply and we put our answer, and again, we're gonna line up our like terms. So x times x squared is gonna be x cubed. The next thing we wanna do, just like in regular long division, you subtract. So I think the first term goes to 0, and then we can bring down, I think that's it, right? Let's just keep going. So if we were to bring down the 0x squared and this guy, if we now if we said 0x squared divided by x squared, or in other words, 0x squared divided by 1x squared is going to be 0, so there's nothing there. If you multiply, you get 0. The 4 comes down. I think the remainder is just -4, right? So I didn't write it all the way out, but I'm just going to say that the remainder is -4, right? So then let me think. So then the solution, this guy is going to be equal to x minus 4 over x squared. But the main thing that we need, I'm going to put it in green. The main thing that we were looking for is this guy right here in green. Whatever your solution is here without the remainder, that's going to be the equation of your oblique asymptote. So in this case, the oblique asymptote is going to be y equals x. All right. So the oblique is going to be y equals x. Okay, I'm wrapping up. So let me just check and make sure that this works, and let's kind of answer the questions being asked, and I think we'll be good to go. It says the oblique asymptote or asymptotes are type an equation. We got y equals x. All right, y equals x. So then y equals x, right? So A is not the oblique asymptote. That's not y equals x. It's either B or D, because those are the graphs of y equals x on the oblique asymptote. And then we need to like confirm a few other points, right? For instance, when x is 2, let's do when x is 2. So when x is 2, 2 cubed is 8 minus 4 is 4. 2 squared is 4. 4 divided by 4 is 1. Notice it's positive when x is 2, right? Let's see. Okay, I think they're positive. It still could be, I think it could still be either B or D. Let's confirm another point. Some more points. Let's do when x is 1. Yeah, let's do when x is 1. So when x is 1, on top, we're going to get what, -4. On bottom, we get 1. So it should be negative when x is 1. Right? Okay, I think that gets it for us. Because if you look at B when x is 1, it's still positive. But when you look at D when x is 1, it's going negative, which is what we got. So we're going to go with D. All right, I just chose a few points and confirmed it. Okay. All right. So on that note, we're going to end the session here. Do you guys have any other questions before we kind of part ways? Okay. So let me see. So we just kind of closed out. Oh, the attendance thing.
Yeah.
Okay. Anybody have any other questions before I do that? Okay. So let me see. So next week I think it's section 3.1 on exponential functions. Just be sure to kind of, I don't think I've created a lecture for that yet. So I'll go ahead and I'll try to make that at some point soon. Try to get there early so you can look at it in advance. My recommendation, try to watch that lecture in advance and then come to class on next Wednesday and Friday with questions. The homework is assigned already. You're welcome to go ahead and get started. And like I said, I'll make a lecture for that. I'm going to keep going on. I'm going to stay on the stream and go ahead and get the students squared away. But as far as the YouTube live stream, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, take care. Peace. I'll be right with you. Let me just end the stream.